أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. My name is Dr. Aref Wazwaz from Chemical Engineering Department, Jafar University, Salalah, Oman. My presentation title is Solar Desalination of Seawater Using a New Design. Let's start with the introduction. Safe drinking water is the most international essential issue to save the needs of human. Unfortunately, more than 1/6 people still lack of healthy water with the safe specifications. This problem is particularly present in developing countries. Each person on earth requires at least 20 to 50 liters of clean, safe water for drinking, cooking, and simply keeping themselves clean. 1.8 million people die every year of dihedral diseases like cholera because of polluted water. The properties of safe drinking water supplies can be specified by 4 important characteristics: quality, quantity, reliability, and cost. The United Nations and other organizations estimate that each person needs a minimum of 20 to 50 liters of water per day for drinking, food preparation, and personal hygiene. The World Health Organization, WHO, and various national agencies have drinking water quality standards that specify the acceptable microbial, chemical, and radiological characteristics of safe drinking water. There are many sources of water that can be converted into potable water, like underground water, sea, rivers, waterfalls, etc. There are different techniques to produce fresh water, such as multi-effect evaporation, multi-stage flash distillation, thin film distillation, reverse osmosis, and electrodialysis. However, all these techniques are expensive, but solar desalination illustrates one of the best options economically and applicability in Gulf countries, and especially in Oman, where solar energy is available and plenty most of the year. Solar radiation is plenty all over the year in Gulf countries and especially in Oman. So we can combine between solar energy and purification of seawater to have potable water, healthy water. You see, you have sun radiation using seawater, then the distillation, solar desalination process to have pure water. The experimental part, the procedure is done according to the following flow chart. We made a design, manufacture of the design, the prototype, and we have the distillation process using as input seawater samples from Ad-Dahriz region, Salalah, Oman. Then the result is purified water. We analyzed this purified water and we found it is very close to the standard properties. This is the schematic diagram for solar desalinator prototype. We have input seawater here. Then this is the solar desalinator, which composed of, inside we have black stainless steel, which is absorber, and we have on the edges mirrors with height of about 10 centimeters. And we have here the movable reflector. This is glazing hole. This is tunnel to collect the condensed water. And here the output desalinated water, purified water. Here the specification of the solar desalinator prototype. Here the total volume, total surface area, absorber area, surface area for condensation, surface area of reflector. This is the actual picture of the solar desalinator. This is for the input water, which is seawater. Here inside the evaporation and condensation. Here movable reflector can be put here, and here the collected purified water. Here this is the tunnel to collect the condensed purified water. These are the mirrors around, and the results and discussion part. First of all, the chemical analysis of water before and after solar desalination. Here the specifications, a lot of specifications, physical and chemical properties before solar desalination. This is the specification of the seawater. This is after solar desalination, pure water. This is the standard value according to Omani standards for healthy water, drinking healthy water. And we find that pure water we reduced and very close to the standard values. Biological analysis. Biological analysis for sample before and after solar desalination. This is before. This is for the seawater. This is after for the pure water. This is the standard values. Almost the result very close to the standard values. See the efficiency of solar desalinator prototype and the rate of collection. Here percent efficiency of our solar desalinator for different input volumes. Here the seawater input volume, here the output pure water, here the percentage efficiency per day. We start simple one with 500 ml seawater, then we produced 90 ml. The percentage efficiency per day is 11.788. Then we put 1000 to produce 210. The efficiency is 12.3 percentage. So we have 8 samples, and we find that the average percentage efficiencies per day for the 8 samples is 16.063 plus minus 3.36 percentage. As we see from table 4, the average percentage efficiency obtained was 16.063 plus minus 3.36 percentage, with the production rates in the range of 0.6 to 3.0667 liter per meter square of the absorber area per day. So if we plot, this is figure 3, if we plot percentage efficiency with the input volume, we can get almost a straight line. This is the equation of the straight line. This is the correlation coefficient, which proves that it's very close to 1, which means that it is almost, we have linear relationship between percentage efficiency with the input volume, which is the seawater. Figure 4, this is the relationship between output volumes with the percentage efficiency. As we see, this is the y-axis, percentage efficiency. This is the x-axis, output volume, or which is purified water, which is very close. You know, we have, this is the equation of the relation, and it is a linear equation, and from correlation coefficients R squared, which is 0.848, it is very close to linearity. Figure 5, relationship between accumulative solar flux with the percentage efficiency. This is the y-axis percentage efficiency, and the x-axis accumulative solar flux, watt per meter square. We find also we have linear relationship according to the correlation coefficients R squared, which is 0.983, which is very close to 1. This is the flow rate, liter per meter square day, with the percentage efficiency, and we see also we have very close to the linearity, as we see from the correlation coefficients R squared, which is 0.848. In a previous study, we used different design and obtained an average percentage efficiency which is 11.856 plus minus 0.001 percentage, with a production rate of 2.38 liter per meter square day. The conclusions, we concluded that a new design of solar desalinator prototype, which is different from that we used in our previous research, is better than before. We use aluminum foil as a reflector, and it is a movable, actually a movable reflector. And also use the water wetted cloth to increase the rate of the condensation. The seawater samples were taken from the Dahriz region Sarara from the sea there. The experimental tests started every day from sunshine till sunset. The fresh water collected was accumulative water during the whole day. The average percentage efficiency obtained was 16.063 plus minus 0.001 percentage, and the maximum efficiency obtained was 21.525 plus minus 0.001 percentage, which is better than our previous study for the different design. The collected fresh water is close to Omani standards of safe drinking water. We obtained better results by the new design than that of previous design we used in the previous research study. Thank you very much for your attention, and a great best wishes for all. Thank you very much.